Today we're going to talk about prisms and more specifically the volume of prisms. So we're going to talk about Cavalieri's principle and we're going to use that to talk about some theorems. So we're just going to look at the principle and kind of explain Cavalieri's thought process. We're going to get a formula for the volume of a prism and then we're going to find volumes of prisms using that formula. Okay, so let's talk about Cavalieri. He was a mathematician, and he came up with this idea. He said if you have two solids, okay, and all of the planes are parallel to a fixed plane, and all of the sections of those two solids have equal area, then the solids have the same volume. So you're like, well, wouldn't they just look like the same solid if all of the cross sections or all the sections have the same area? Well, let's look at this. Okay, let's say we have this guy and we have this guy, right? And this looks like it's just kind of slanted, kind of like the Leaning Tower of Pisa, right? Well, you're like, well, are those the same or not? Do they have the same volume? Can we fit the same amount of liquid inside them if they were hollow? Okay, well, let's think about it. Is that area equal to that area? Yes. And do they fit the same amount of area? They do, which means that they have the same volume. So next thing, a cross section of a prism is congruent to the base of the prism. Okay, so what is a cross section? It's the intersection of a three-dimensional figure in a plane that passes through the figure that is perpendicular to the altitude. So I think about it like this. Think of a loaf of bread. The entire loaf is your 3D figure, your three-dimensional figure. But if you cut just a slice, if you were to take a knife and cut a slice, you are getting the cross section. Sometimes it looks like a nice little piece of bread. Sometimes it's a little crazy on the top, but it is a cross section of that entire loaf. It doesn't necessarily look like the loaf because it is a cross section, okay? So the theorem we just talked about, it's referring to the cross sections. Those are the things that are parallel to the basis. Okay, so those are the same. They have the same area. Okay, so let's look at this. This guy here, his cross section looks like this, right? That's his cross section. Whereas this cross section looks like a rectangle. All right, so now let's talk about the formula for the volume of a prism, and that's equal to V is equal to base times height. And when they say base, they're not just saying base as in like a number base, like 8. They're talking about the area of the base, the area of the base. Okay, so for this example, if we wanted to find base times height, we're not saying 8 times 14 square roots of 3. We actually need the area of this entire base, of this entire hexagon. So we had to go back to our area formulas and remember, how do we find the area of a hexagon? Remember, we had to get the apothem, right? The line that goes from the center here. Okay, so our apothem ends up being 4. Okay, so in order to find the apothem, the first thing we want to recognize is that if this is 8, this is 8, and this is 8, because remember, your 2D figures are going to make triangles, right? And those triangles will have the same distance. So if this is 8, then this is 8. And the apothem is going to bisect the side, which means that this is 4 and this is 4, and you have two little triangles inside your big equilateral triangle. So now that we did that, we have a side of 4, a hypotenuse of 8, and a missing a for this side, which means we can use Pythagorean theorem. So a squared plus 4 squared is equal to 8 squared. Okay, we solve for that. So a squared plus 16 is equal to 64. Subtract 16 from both sides. So a squared is equal to 48. And so that means a is equal to the square root of 48. If you want, you can just write it as a equals 4 square root of 3, or whatever that ends up being in your calculator. So now we have the apothem. The apothem is not the area. In order to find the area, we have to do the area is 1/2 of the apothem times the perimeter, right? So the apothem was 4 square roots of 3, and the perimeter is 8 times 6, right? Because it's 6-sided, so 48, which means if we calculate all that out, we get 96 times square root of 3 square units, because it's area, okay? If you're using your calculator, you would end up with around approximately 166.3 is what you would get. Okay, so that gave us the area of the base. We are still not done. We've just figured out the B part, right? So volume is V is equal to base times height. So our base was approximately 166.3 or 96 square roots of 3, and our height is 14 square roots of 3, okay? So you multiply those together and you end up with 4,032 cubic units, right? Because volume is cubic, just like area was squared. All right, so here is a refresher on all those area formulas that we learned. You are going to need to know them in order to do volume. So go ahead and rewrite these down. If you don't have them somewhere, write them down now so you have them. All right, so let's practice. So we have a figure here, and we need the area of the base times the height in order to find the volume. Well, we don't really have the area of the base. We have that this side is 6 and this is 10, but in order to get the area of a triangle, we need to know the height of it, right? So we need to know this missing side. So we had to use Pythagorean theorem, right? 6 squared plus x squared is equal to 10 squared, right? So 36 plus x squared equals 100. Subtract 36, square root, you get x equals 8. So we now know that the height of the triangle is 8. So now we figure out the area, which is base times height divided by 2. So 6, which is our base, times our little base, right, times height, which is 8, divided by 2, which gives us 24. Okay, so the area of the triangle is 24. Now going back to volume, we get volume equals big H and big B, and big B stands for the not the just the base, but the area of the base. So that's 24 times the height, which is 12. And that will get us 288. All right, so let's talk about a new definition. There's something called a semi-perimeter, and that is half of the perimeter of the triangle, okay? So you add up all the sides of the triangle, the A plus the B plus the C, and you divide it by 2, and that gets you a semi-perimeter. You're like, well, why is that useful? Well, there's something called Heron's formula, okay? And it's another way to get the area of a triangle, and it's supposed to be easier than trying to figure out doing, Pythagorean theorem and figuring out the other side, okay? So what you're going to do is you're going to do area is equal to S, which was the number that we calculated before, A plus B plus C divided by 2, times S minus A times S minus B times S minus C. And that will get you your area of a triangle. Okay. So now let's look at this guy. We want to find the volume. Okay, so first we have to look at the base. We know that this is 6, which means that those sides are also 6 because it forms an equilateral triangle. Now I could say that, well, this means that this is 3 and this is 3. I'm going to use Pythagorean theorem and find the apothem, right? Or, here we go. Sorry, I lost my train of thought. Let's go ahead and just find the apothem, right? So 3 squared plus a squared, and remember a is going to be our apothem, is equal to 6 squared. So solving for a, we get the square root of 27, which is approximately 5.2. All right, so the area of our base, which is a hexagon, is half of the apothem times the perimeter, right? So half of a, our perimeter is 36, right? Because it was 6 and 6 sides, and our a was 5.2. So in the calculator, that gives us 93.6. All right, so that just gives us the area of the base. We need the volume of the entire thing. So where our base was 93.6 and our height was 24. So our volume is 2,246.4. And our units are millimeters, but remember it has millimeters cubed because we're talking about volume. All right, that's it for your notes. Go ahead and attempt 9.2, number 2 through 6 evens. Remember, I'm going to expect you to turn in 2 through 6 evens with your notes. They're going to be due for a grade when I see you in class. All right, thank you. Oh, and I'm sorry, it says 9.2, and that's an error because it should say 11.2, right? It's 11.2, 2 through 6 evens. Sorry, that's a typo. So 11.2, 2 through 6 evens. All right, thank you all very much.